In this video, we're going to have a look at the 3 different log laws. We're going to look at how to apply them and kind of different examples that you might see. Let's get into it. Okay, so the first log law is called the addition law. And basically it is when you have log base a of x plus log base a of y. This will give you log base a of xy. So you can split that up there. That's the first one. The next one is the quotient law, and basically it's similar to the one above, but you have subtraction instead. And what you're going to have is log base a of x divided by y. Okay, so that's number 2. And the last one is kind of called, I suppose, the power law, and that's basically when you have log base a of x to the power of y. And what you can do is you can bring the y to the front and make that y log base a of x. So these are the 3 log laws that we're going to be using today. All right, so here's the first example. We have log base a of 4 plus log base a of y. When you have an addition, all you need to do is just bring them all together. So you're going to have log base a of 4y. It's pretty straightforward. Now, one thing you want to obviously be careful of is the bases have to be the same for both. Otherwise, you can't combine them. Okay, let's look at the next one. You've got log base a of b minus log base a of 10. This is going to be the quotient one, so this is log base a of b minus 10. Okay, let's have a look at another example. So let's say you've got log base a of 3 squared. Now, one way you could do it is obviously just square the 3 and make that log base a of 9. But another way you could do this is using the power law, where you put the 2 at the front and make that log base a of 3. So these 2 are equivalent. Okay, let's look at the next one. So the next one, we've got 3 log base 2 of 2 plus 2 log base 2 of 4. Now, the bases are the same, so that means I can use some of the log laws. But I've got a 3 and a 2 here, so I need to figure out what to do there. I can't just add them straight up, because these are kind of like not like terms right now, because the 2 and the 4 are different. So what I want to do is I want to bring this 3 back up to the power and bring this 2 back up to the power. That's going to give me that's going to give me log base 2 of 2 cubed plus log base 2 of 4 squared. All right, and now I can simplify this bit. So I can simplify the powers. I've got log base 2 of 8 plus log base 2 of 16. All right, now once you've got to this step here, you always kind of want to ask yourself, can these logs be simplified in and of themselves? So in other words, what this means is it's saying 2 to the power of what gives you 8? 2 to the power of what gives you 8? Well, I know that that's going to be 3, right? And on here, 2 to the power of what gives me 16? Well, that's going to give me 4. So my final answer here will be 3 plus 4. Well, that is 7. Done. Let's have a look at this example here. We've got log base x of 1 on 6, and I just need to simplify this, okay? Now, what do I know about fractions and indices? Well, I know that log base x of 1 on 6 is the same as log base x on 6 to the power of minus 1, because that there here is equivalent. Now I can bring my power to the front, so I can write minus log base x of 6. I'll just leave the 1 out because you don't really need to write it, but that's where it would go. Okay, let's have a look at these type of questions here. Now here you're going to get these kind of 2 given equations. It's going to tell you log base a of b is equal to 3.4 and log base a of c is equal to 4.7. And we need to kind of use these to kind of manipulate and figure out how we can apply them to these specific questions. So here we've got log base a of bc squared. All right, there's always, multiple ways to do these questions. So I'm thinking what we've got here is I've got BC, okay? And that's squared only with the C. So I'm thinking maybe let's split this up into addition. And we can write this as log base A of B plus log base A of C squared. All right, and now I can bring this power down. So I can write this as log base A of B plus 2 log base A of C. And now, hopefully you can see I've got a really nice substitution where I can just switch these 2 out for the 3.4 and 4.7. So log base A of B is 3.4 plus 2 times log base A of C, which is 4.7. So that's 3.4 plus, what's that, 9.4, I think. So 3.4 plus 9.4 is 12.8. Done. Let's try to simplify this one here. We've got log base a of bc all squared. Now this one's a little bit simpler than the one before because what I can do is just bring the 2 up the front like that using the power rule. So it's 2 log base a of bc. Now remember, bc is just an addition here. So you'll have 2 bracket log base a of b plus log base a of c. And now I can do my quick substitution. So it'll be 2 outside of 3.4 plus 4.7. So 2 times, what's 3.4 plus 4.7? That is going to be 8.1, I believe. And 2 times 8.1 is 16.2. Done. Okay, let's try to do this one. So this is log base a of a cubed. Now once again, using the power rule, I can stick the 3 at the front. Log base a of a. Now what you'll hopefully realize is I don't actually have a substitution for log base a of a. However, I know that this is another way of saying a to the power of what is a. Okay, a to the power of what is a? Well, a to the power of 1 obviously is going to be a. So this is going to be 3 times 1. So my final answer will be 3. All right, last one for today. So here we've got log base a of a over c. So I can see here I've got a quotient, or in other words, division. So what I'm going to do is split that up to write that as log base a minus log base a of c. Now remember from the last example, log base a of a is just saying a to the power of what is a. So that's going to be 1 minus, and log base a of c is 4.7. What's 1 minus 4.7? Well, that is going to be, I believe, minus 3.7. Done. All right, that's it for today. If you enjoyed this video, let me know by liking it down below. If you want to see more videos like this, subscribe and let me know in the comments. Thanks for watching. I'll see you in the next one.